Hello friends, you can log on to primeaptacademy.com to access complete free video courses. So this is the 23rd question of the SASMO 2019 exam for grade 10 students. So question says, in the diagram, ABC is a right angle triangle with AB as 15. So AB is 15 and BC is 8. So BC is 8. Okay. Point D, so it doesn't say, but you have that angle B is 90 degree. That is an information missing in this question. So you have to assume that angle B is 90 here. So if that is the case, AC will become 17. Okay, AC the hypotenuse. In fact, it says the hypotenuse AC. So if hypotenuse AC, then this is right angled at B. Okay, so the question says that further. So it doesn't explicitly say that angle B is 90, but it says AC is hypotenuse. So that means B is 90 degree. So AC is 17 according to Pythagoras. So if this is 15, this is 8, this will come out to be 17. Point D is on side AB such that DB is 6. So DB, this part is 6. This part is 6. That means AD is 9. That means AD is 9. Point E is on the hypotenuse AC such that DE is perpendicular to AC. So this is also 90 degree. Find the length BE. We have to find BE. So you have to join BE and find that. Okay. So what I will do is I will use some other color. So let me join BE here. This is what we have to find, BE. Okay. So now if you look at it here, first of all, if I take triangle ABC and ADE, angle A is equal to angle A in both the triangles, triangle ABC and ADE. Then angle B in triangle ABC, which is 90 degree, is same as angle E over here in ADE. It is also 90 degree. So that means the third angles, angle C should be equal to angle D. Okay. So from here, what do we conclude? Triangle ABC is similar to triangle AED. ABC is similar to AED. So from here, similarity, what we conclude if I find the ratios, AB upon AE, AB upon AE is equal to BC upon ED is equal to AC upon AD. AC upon AD. This is what we have computed from similar triangles. Now we'll plug in the values that we know. AB we know is 15. So AB is 15 upon AE. AE we don't know right now. Is equal to BC. BC we know is 8 divided by ED. ED we don't know right now. Is equal to AC upon AD. AC we know is 17 and AD we know is 9. So this is what I get. 15 upon AE is equal to 8 upon AD is equal to 17 by 9. So from here we can find AE and ED. That is what we're going to do. So we'll take 15 upon AE is equal to 17 upon 9 first. So 15 upon AE is equal to 17 upon 9. So AE will be then equal to, this 17 comes over there, 15 into 9 divided by 17, which is equal to 135 upon 17. So AE is 135 upon 17, AE. This much part is 135 upon 17. Okay. Further then, 8 upon ED is equal to 17 by 9 also. 8 upon ED is equal to 17 by 9. So ED will be then equal to 8 into 9 is 72. 72 upon 17. So ED is 72 by 17. ED, this part is 72 upon 17. So this ED over here is 72 upon 17. Okay. Now I know AE is 135 by 7. AC is 17. So EC we can find. So EC will be, EC is what? 17 minus 135 by 17. So EC is 17 minus 135 by 17. So 17 into 17 is 289. 289 minus 135 by 17. That will be equal to 9 minus 5 is 4. 8 minus 5, 3 is 5. 2 minus 1 is 1. 154 upon 17. So EC is 154 by 17. So EC over here is, what I'll do is, write it over here. EC is 154 upon 17. Now, if you look at it, now we know that we have this quadrilateral BCED. Okay, let me use some other color also. I'll also create another diagonal DC. So DC is another diagonal. Now if you look at it, if you just want to find the length of DC, BDC is a right angle triangle. Okay, because angle B is 90 degree. This is 6 here, this is 8 here. So DC should be then equal to 10, because DC is the hypotenuse of this right angle triangle with sides 6 and 8. So the hypotenuse will be under root of 6 square plus 8 square. So DC should come out to be 10. So DC is 10. Also in this quadrilateral, if you look at it, in the quadrilateral BDEC. So I'll use it over here. Let me write over here. In quadrilateral BDEC. Angle B is 90 degree, angle E is also 90 degree. So angle B plus angle E, which is opposite angles, sum is 180 degrees because both of them are 90 degree. So that means angle D plus angle C should also add to 180 degree. Okay, because all the 4 angles should add up to 360. So angle B plus angle E is 180. So angle D and angle C is also 180. That means if opposite angles are adding to 180, that means it is a cyclic quadrilateral. That means BDEC is a cyclic quadrilateral. Now applying the theorem for cyclic quadrilateral, we know that the product of the diagonals is BE into DC. BE into DC should be equal to product of the sides, sum of them should be equal to DE into BC, first of all, DE into BC plus DE into BC plus DB into EC. DB into EC. Again, the product of diagonals in a cyclic quadrilateral, which is over here DC into BE, this is equal to sum of products of the opposite sides. Means sum of product means this is DE into BC plus DB into EC. Okay, so this is the theorem of cyclic quadrilateral. Now what do we have to find? We have to find BE. That is what we have to find. We know the value of DC, which is 10. We know the value of DE. We know the value 72 by 17. We know the value of BC, 8. We know the value of EC, 154 by 17. And we know the value of DB, which is 6. So we know all these values. So we'll just plug in the values here. It is BE into DC. DC is what? You have to round off your answer to the nearest integer also. Okay. So DC is what? DC is 10. DC is 10 is equal to DE. DE is 72 by 17 and that is 8. So this is 72 by 17 into 8 plus DB. DB is 6 and this is 154 by 17. 6 into 154 by 17. If you find out the value and through this, BE will be almost 8 point something, close to 9, will be almost equal to 9 after you round off. So BE almost comes out to be 9 after rounding off. So 9 over here is the right answer. Alright, this was quite a complicated question. That's how you do this.